Hello viewers, welcome to Elimu TV where you watch and learn. I'm your tutor, Alex Musawa, and I'll be taking you through Physics Form 3, lesson number 28, and our title is Refraction of Light. The objectives of this lesson are to describe what is refraction of light, number 2, to find out how refraction of light occurs in various media. As you can see from the diagram, that is a pencil. And as you know, a pencil is not bent, it's straight. But when you put it inside a glass containing water, the pencil appears to have bent. Why? This is because the light that comes from the sun as it is reflected to the pencil is refracted. That means the light bends. And the bending of light causes the pencil to appear as though it is bent. Even a coin, let's say you put a coin in a beaker containing water, the coin appears to be floating, it appears to be halfway. Why is it that way? Because of refraction of light, the bending of light. Those are some of the experiments you can carry to find out the bending of light. Okay, we are going to investigate refraction. And what is refraction? As you can see, refraction is the bending of light as it travels from one medium to another. You can see the incident ray. As it falls on the surface, it is refracted. That means it bends. And we have the angle of refraction. That is the angle between the normal and the refracted ray. And we have the angle of incidence. That is the angle between the incident ray and the normal. Can we explain that? Light travels with a velocity of 3.0 times 10 raised to the power 8 meters per second in vacuum. It travels with a velocity slightly lower than this in air. In other transparent materials such as water, glass or perspex, its velocity is greatly reduced. That means that light travels with different velocities in different media. An optically denser medium has a greater refraction effect on light than a less dense or rarer medium. When light travels from a less dense medium air to a more dense medium glass, it is refracted towards the normal. The angle of incidence is greater than the angle of refraction by the principle of reversibility of light. We have the laws of refraction, and there you can see we have Snell's law. That means the sine of the angle of incidence divided by the sine of the angle of refraction gives us the refractive index. And that is a graph. As you can see from the graph, we have plotted a graph of sine of angle of incidence against the graph of sine of the angle of refraction. And what happens when you find the gradient of that graph? The gradient, let's say the equation is sine I is equals to n sine r. The gradient of that graph gives us the refractive index of the medium where the graph was plotted, from which the light fell. So that is how we find the refractive index using a graph. What is refractive index? This is the measure of how much light slows down when it goes into a new medium. The symbol is n. And n, one of the formula of finding refractive index, the n is equals to the speed of light in vacuum or over the velocity of light in the medium. As you can see, we have also refraction through successive media. That is from, let's say, from air to water, from air to glass. As you can see, we have the refractive index of air, which is 1 there, and the refractive index of water, which is 1.32. the rays are coming from air into the water. For light traveling from 1 to 2, the refractive index is noted as 1n2. That means that light comes from medium 1 to medium 2, and which is equivalent to the sine of the angle of incidence at medium 1 over the sine of the angle of incidence at medium 2. For light traveling from 2 going back to 1, the refractive index is 2n1. That means light comes from media 2 going to 1, and it's going to be the sine of the angle of incidence at medium 2 divided by the sine of angle of incidence at medium 1. That implies that 1 over 2n1 is the same as sine I1 over sine I2, which is 1n2. And that is the end of our lesson. I have an activity for you. Number 1, define Snell's law. Number 2, describe an experiment that you can use to determine the refractive index of glass. Our reference book is KLB Book 3, 5th edition, Physics, year 2019. For more information, contact us on our number: YouTube, Elimu TV; Facebook, Elimu TV; Twitter at ElimuTV_K. Thank you for watching Elimu TV. Stay